You've added some time. Well, okay, how's that work with fueling? How's that work with your boost sensor? How's that work with mass, manifold pressure in the scheme of things? You just if he's an engineer, that's one thing, but I oh.
I'm gonna see how it is.
Well, I don't know. It doesn't sound to me like, I mean, $5 for the whole job?
It's just for the set.
Yeah, no, but are you getting a new intake manifold?
I'm not sure what.
Are you? Well, I'm just saying. Are you getting a new intake manifold? Are you getting a new throttle body? Is it a diesel or gas?
Yes.
Okay. Are you getting a new throttle door? Are you going to go from like an 88 millimeter to a bigger throttle door? Okay. Are you getting recalibrated sensors that can read in the range that you're going to be working at, in the boost range you're going to be working at? How accurate are those? Okay. And not only that, can he plug all the new values into a computer program to make this thing run OEM? I'll give you a hint. No.
Yeah, makes sense.
Well, yeah, and here's the other thing. When you go to SmogDat, it ain't legal. Is he going to put a 50-state legal sticker on there? I'll give you a hint. No, because it ain't built that way, OEM. It ain't legal. So if you want to go around having to pay $1,000 to get that smogged every 2 years because you need a clean truck, have at it.
Sounds like a long way around.
Yeah,
It sounds like a no.
Yeah.
It seems like in a sense.
yeah. And when someone says, don't worry,
You better
it's
worry.
You gotta
free.
worry.
Or trust me.
No, because somewhere down the line, he's going to need a favor. He says, hey, you remember when I did all that work on your truck and didn't charge you? I need a favor.
See, you rephrased it out better.
Well, I mean, he's going to want something. Okay? Put this in the back of your truck. Yeah, it's just a roll of carpet. Don't worry about it. But don't let the cops pull you over. Well, why am I dropping the carpet into the ocean? It's no good anymore. I just want to get rid of it. Oh, I've got to be careful because he said, yeah, Mike, you're right. He wanted me to don't tell me that. I don't want to know. All right. Now, so your crankshafts in our world are forged. In the automotive world, most of them are cast. In other words, they're poured into a sand mold and then machined. That's economical and it gets the job done. But when you start highly modifying the vehicle, it's not the strongest crank in the block. Okay. Now, when we run my crankshaft, okay, how many of you guys believe in reincarnation? Good. If you die, do not come back as a crankshaft. Okay, it's a bad deal. Arco Graphite had a commercial out in the late 70s, early 80s where they ran a camera down into the crankshaft of this engine while it was running. I think they went down the dipstick tube. And you see this poor crankshaft just flexing, just, you know, doing this. When a piston fires on a crankshaft, it introduces all kinds of different loads on it. So here's my rod journal, here's my main journal, here are my counterweights. So on a diesel engine, typically when a piston fires, you got somewhere between a ton to 1.5 tons of pressure instantly released on the top of the piston. Okay? So what that does to the crankshaft is it causes the top of the journal to compress, the bottom of the journal to stretch. Same thing here, compression and stretching. This is why on the crankshaft it's only hardened down to a certain point because that crankshaft has to be flexible. Okay? And at the same time, the crankshaft is vibrating in there. Okay? It's vibrating. Now this is important because how many of you guys remember those old Memorex commercials where I think it was Aretha Franklin, where she hit a certain note and the champagne flute would shatter and then they'd play a tape. Is it Live or was it Memorex? Okay? What that's demonstrating is frequency harmonics. Okay? Everything on this planet exists at a certain frequency. Okay? That's just nature, physics. If the operational frequency of the crankshaft ever equals its natural frequency, it's going to be like that flute, that champagne flute. It's going to crack. Because that's how that flute cracked. The singer's octaves were at a certain frequency that matched the natural frequency of that champagne flute, and that thing just shattered. You could probably Google up that old commercial. It's kind of a cool commercial. Okay? So while my crankshaft exists at a certain frequency, it also operates at another frequency. And we don't ever want those two frequencies to equal or come into harmonics, or that crankshaft will detonate. Fun to watch if you don't have to fix it. Okay? Now, at the same time I'm compressing and stretching my journal, I'm also causing the crankshaft halves to rotate at different speeds. Okay? So while number 6 is coming up on compression and firing, number 1 is coming up on compression shortly after that and firing. So as this side's coming up on compression, it's slowing down. And as this side fires, it actually speeds up. So I got one half of the crankshaft slowing down because this is being forced up in the bore to compress the fuel-air mixture. And the other side fires off. Now this is how a lot of your engine's diagnostics detect a misfire. Because if the cylinder fires and the diagnostics don't pick up a slight increase in the crankshaft RPM, then they consider that cylinder as to not have fired. Okay? Now, you all have seen the front of an engine running, you've seen the little thing, it all looks very smooth. It's like, oh look, it's running. Except in your truck, it may not be running long. Okay? That's actually not the case. If you were to put a slow motion camera on that, it would be very jerky, like bang, 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 at 800 times a minute. So it's not, it's not a good life to be a crankshaft. Because it's doing this on my journals every time the piston fires, and it's winding and unwinding because I got one cylinder coming up, slowing down, and another firing, speeding up. I'm doing this, and you don't want to be a crankshaft. Okay? So add in there a 90-degree angle somewhere because you scratched it, then you've got fatigue. You saw what happened on that pencil, right? Wouldn't take much. They won't let me do that on an engine and break one for class. They're like, no, Mike, we can't do that. I'm like, dang.
Ask the boss.
No, I tried. He just looked at me and said, you want a drug test? I'm like, yeah, no, never mind.
Drug test.
Because you've got to be on something to ask a question. That's stupid, right? It's like, I'm not stupid. I'm just, intellectually challenged and a bit slow. While the rest of you are having a
Well, I always say it.
Jesus.
Stupid is as stupid does.
Well, while the rest of you are working on
I went to look for
a
coffee.
Pentium 5, I'm still working on a
And I
186,
told
all right? So I'm a little slow, but I get there.
because they didn't.
All righty. So, these are the counterweights. When you see the little recesses in here, this is the metal they removed to balance the crankshaft. Now, the question usually comes up, can you rebalance the crankshaft? You could do whatever you want. The question is the effort worth the result? Okay? If you've got a need to rebalance the crankshaft, you've got bigger problems. Okay? But the crankshafts are poured at the foundry. They're pressed into configuration. The journals are machined. And the original machining of the journals is called standard. When it leaves the foundry and ready to get put in the engine, whatever those measurements are, here and here and here and so forth, is called standard, whatever that value is. Okay? Now, after a while, because of all that stressing and flexing and rotating, these metals are going to wear. And that journal is going to become tapered and out of round. So if I'm rebuilding my engine, I've got to get those diameters back into specifications. Okay? So if I have to remove 20 thousandths of an inch off of that journal to get it round, I'm going to need a bearing that's 20 thousandths of an inch thicker because I have to maintain a running clearance between the journal and the bearing because I got to have a specified space for oil to get in there to lubricate the crankshaft. Okay, now the job of the oil, and we'll talk about this later on, is to form a wedge so when the crankshaft is rotating, it's not really rotating on the bearing itself, it's rotating on a wedge of oil between the bearing and the journal. If the gap is too big, I can't make that wedge. If the gap is too small, I can't get enough oil in there, and I'll eventually overheat and lock the motor up.
How long do those bearings last, and as far as mileage?
Just wondering what.
I mean, if I change my oil every election year,
Exactly.
it'll
So
fail.
they fail.
Yeah, it's like, will the plane get me there? Yep, it always gets you to the scene of the crash. There's too many variables to figure that one out. But it's not unheard of in tractor trailer world, several 100,000 miles. In fact, when I was at LA Unified, we had an owner of a small fleet of trucks. He had 5 trucks. And so his business slowed down a bit, and he brought the highest mileage truck in. Now this is his story. It had 900,000 miles on it. Now I saw that on the computer because we pulled it up on Detroit and it said mileage 900K. And he said it'd never been rebuilt. He's bringing it in because it's just down on power. He's like 3 gears lower than the other trucks going up grade. So he says it's time to freshen up the motor. So if his story is correct, and I have no reason to believe it wasn't, he went 900K.
A lot of variables are in there. How often
Depending on the maintenance, they go
oil.
What's that?
The air cleaner. Did you keep your air induction system?
Depending on the maintenance, they go longer than that, 'cause my brother's a truck
A
driver.
whole lot of different.
And
How was it
He bought his
driven?
truck when
Was
he
it
had
driven hammer
100,000
down,
miles.
or was it
And
daily?
he did the first rebuild at $1,300,000.
It's hard to
Yep.
put an exact.
That's
number.
not unheard of at
You
all.
do that with-
Especially if it's a fleet truck, like a large fleet, because they got awesome maintenance programs.
Cause he's the one that, it's his truck, you know, so he does the maintenance meticulously on
Yeah,
it.
sure.
And it lasted $1,300,000, so
Yep.
I mean, they can go really far.
That's-
Well, I helped this student when I worked at LA Unified. He bought an old JB Hunt when they had the cab over at Internationals. He bought it for $5,000 or $6,000. Or yeah, it was cheap. Had like 600K on it. So he brings it to class. We put an engine in it. It was a L10 and an Eaton 10-speed. So we built the engine, built the transmission. He went out and got a new set of drive axles on it. 10 years later, my wife and I are on vacation up in Independence, California. We're at the McDonald's getting some Big Macs or whatever, and I hear this, Mr. Tingley, and I'm like, oh crap, did I arrest this guy? So I turn around, and it's that guy. And I look out, he's still running that truck. He says he hasn't opened it up since he built it at LA Unified 10 years later. So, yeah, you take care of them, they can. And this guy was fastidious about, so I know he did good maintenance on it. Like Frank was saying, if I don't do good maintenance on it, you could choke a diesel in 200K. You know, air cleaner's plugged up, raises the operating temperature, dirt gets in the air, which gets in your cylinders, which gets in your bearings, which gets in your oil. I mean, it goes downhill quick. Right?
Too much idle time.
Well, yeah, diesels don't like to idle. You know, because then you glaze the cylinder walls and now you don't have any sealing. But yeah, $1.3 million is not unheard of. Not unheard of. This guy pulled his down at 900K. So yeah, that's not unheard of at all. Okay. So now the crankshaft has a little bit of in-play in it, and it's that way by design because what happens again to metal when it warms up, it expands, right? So if I don't have a little in-play in this thing and it warms up, it's going to bind up against the block, and now we got problems. So another measurement you have to do when you're assembling the engine is checking the in-play. So what you do is you put a dial indicator on the end of it, which is just a dial gauge with a plunger, and move the crankshaft back and forth and see how much in-play it has. And 15, 16 thousandths is unheard of. Tighter clearances are out there, 10 thousandths. All depends on the OEM. And on this particular engine, this particular picture, in-play is controlled by this thrust bushing. Okay, if there's not enough, I change this out. If it's too much, I get a thicker one. If it's not enough, I get a thinner one. On the engines out there, that number 4 main bearing journal had the shoulders on it. Those shoulders are what control that crankshaft's in-play. Okay? Should you check it? Absolutely. Now, is Acme Speedy Build Motor going to? No, he's just going to throw that thing together and you know $8,000 and put it in your truck, and you just hope it runs. You buy a quality rebuild Cummins Recon, 18 grand. Yeah, that's checked. They'll probably provide you with the build sheet if you ask for it. Okay.
Automatics tend to have a lot of problems with those when you get torque converter controllers pushing up against the crankshaft all the time. Running the clips that would do that would go with belts. As soon as you got on it real hard on the freeway, it would go with belts. and then so we check it for
Oh,
end
they
play.
jump the bill.
Yeah, you could actually watch it, when we put a fiber optic on the boat, you could watch it go, boom.
Yeah, that's, yeah, then the pulley goes out of line with the tosses, but yeah, that's not good. That's not good. So we talked about radiuses and the importance of the correct radius. Now, again, when you go to the machine shop, hang on, oh, my coffee's ready? Good. When you go to the machine shop, an indication that the machinist knows what he's doing is the radius after he's cut my journal. Back. So when I go to the machine shop, my machinist is going to cut all my surfaces. And when he's done, there's going to be a radius between here and here. Okay, there should be a radius. If there's a sharp edge, he didn't do you any favors. If there's a 90-degree angle between this journal and the counterweight, measured right there, that crankshaft's going to fail. Now, if there's a radius, and this particular example, 0.1 to 0.130, so 100 thousandths to 130 thousandths of an inch, that's the spec for that radius. If it looks like this, that thing's going to fail. You know how you fix that? Costs you $4.95. That's about how much a for sale sign costs at Ace Hardware.
Crankshaft for sale.
No, trunk for sale. If it's in the trunk, you don't want any part of it. Okay? So sharp edges, and then again, that pencil is a prime example of what's going to happen. Now, when you put in rods that have bolts as opposed to, or nuts as opposed to bolts, so the rod has a threaded stud sticking out of it that you put the nut on to secure the cap, you better put some coverings over those threads, because if you scratch your crankshaft with that, crank's got to come out and be machined. You got to machine that scratch out of it.
Piece of hose.
Yeah, piece of hose. You can, I mean, if you're really, you know, if you're rich, you can go to Cummins and buy the ones that say Cummins on them for like $100. Just saying. Looks good, you know, you look cool. Looks cool, right? Cool.
Looks professional.
Yes, looks professional. Even though you're as dumb as a brick, at least you can pass yourself off as knowing what the hell you're doing. Right? But yeah, you have to put those on there. Because if you, because when we put pistons in, it's kind of brutal. You take it in there, you put it in the ring compressor, you situate it properly in the bore, and you beat it down into the bore. And if you're not careful, if those studs bang into the crankshaft as it goes down on the bore to get seated, and you nick that thing, you've just wasted that crankshaft. Now your in-frame has turned into, you've got to pull the motor out and get the crankshaft out of it. And if you make a habit of doing that in your business, you're not going to be in business very long. Oh, I went to Acme Engine and I blew up my crankshaft just after they got done with it. Okay? So anywhere you put a sharp edge on that crankshaft, either intentionally or unintentionally, you run the risk of a failure. Now, if you look in the book, there'll be a minimum diameter that crankshaft can be before you have to discard it. Okay? That's because the hardened bearing surface only goes so deep into the shaft, because the shaft has to be pliable, for how I explained earlier. If it's case hardened all the way through, that thing's not going to flex, it's going to shatter. So the OEM on the crankshaft, they'll harden it to a certain depth. And this is why if you try and machine this thing past the minimum diameter, let's see, roll the dice. And you roll it every time you start the truck. Let's see, am I going to get snake eyes today? Ah, crap, I just broke the crank. Now your neighbor will be like, dang dude, that sounded awful. It's fun to listen to, but I'm glad I don't got to fix it. Because when that happens, your block is wasted. There ain't much you can fix. Not much you can salvage. Okay? So the hardening goes only so far. Okay? So when you're machining the crank, okay, you have, like I said earlier, you have to maintain the original dimensions. So whatever I take off of the journal, I've got to add to the bearing to maintain my running clearance. Now, again, you go back to the Acme engine guy selling you a $7,000 motor, is he gonna check that? No. He's gonna throw another set of standard bearings on it, bolt everything up. Now, again, if the clearance is too wide, you're gonna have oiling problems. Okay? If it's too tight, you're gonna have oiling problems. Exactly, or minimal. Okay, this is why when you reassemble an engine, okay, there's a couple of ways you can verify your work. Okay, now this is plastic gauge. It's a very precise thickness of wax that when I lay it on the crankshaft and I cap the bolt, I put the cap on and I torque it to spec, it's going to spread like you see here. And then I use the paper that the plastic gauge came in and I compare it. And I find the one square that matches up to the width of the spread of the wax, 50 thousandths of an inch. That's my clearance. Is this good? Oh, absolutely. But if you build the engine right, you'll know what that's going to be long before you put it together. Because what you'll do, you'll get the crankshaft back from the machine shop, you'll measure the journal, you'll get your rod caps, you'll put your bearings in, you'll torque the cap to spec, you'll measure this, subtract it from that, and you should come up with the running clearance before you put anything together. This is just to verify you were correct. Not only that, if I put my cap in, I torque it to spec and it doesn't crush at all, I might have the cap on backwards.
Had the wrong bearings.
Or you could have the wrong bearings in there. There's nothing says that, you know, you buy a rebuild kit and you get, you specify, you know, a 20 over set of rod bearings that one of those boxes doesn't hold a set of 30 over. I mean, the guy they're paying $8 an hour to stuff the, you don't know.
It's
like
worse when you
silver
ask
part
for
box.
standard. I just asked for standard, and they gave me the wrong bearing.
Yeah,
I'm like, what the hell? Completely wrong engine.
yeah. That's why when, you know, when my brother's building race motors, he spends a good week measuring. Pre-assembles it, measures, writes all the values down, corrects any problems there. Then when he goes to put it together, final assembly, he knows it's going to go to that together. And if there's a problem, it's because he did something wrong, not that the components are wrong. And he knows that, oh, it's not rotating, oh, I have caps, whatever. So it takes time to build these things correctly. Okay, so your connecting rods in our world are forged. Some of them will have a little spray nozzle up here to lubricate the wrist pin, and older engines will have a little nozzle at the top to spray the bottom of the piston. Okay? So when you put the bearings in, you have a cap bearing, which is usually solid, or it may have a groove, and you'll have the rod bearing, which should have a hole that when you put the bearing in, should line up with the oil hole. If you put the bearing in and the hole don't line up, you got the bearing in wrong. Turn it around. There's a little locking tang on the bearing that locks onto the rod, keeps it in place. Okay? You've got a piston pin bore up here that has tapering out around the specs. Now, can you machine rods? Yeah. Do you? No. You buy new rods. I don't buy reman rods. I don't trust them. Because I don't know who remanded it. I don't know what their skill set is. Right? So I'll buy new rods. There's not a big difference in price, but there's a lot of difference in feeling when you put it together. Like, oh God, there's a noise in this thing. I hope it's not those cheapy Acme universal rod. Right?
You don't know if they clamped it by the small end and then torqued the big end.
Yeah, who knows? Who knows what and how they did. So that plastic gauge is used to verify bearing to crankshaft and main bearing to crankshaft clearance. If you've done the build sheet and done the math, you know it should already be what the running clearance is. So on paper, if you fill out a build sheet, you're going to know everything should go together. And if you run across a problem on paper doing your measurements, you can fix it relatively quickly. Now the bearings themselves are Babbitt bearings. They're made of different materials. So you've got your locking tangs, your bearing face, angular groove oil hole. Okay, and they're made of aluminum, lead, nickel, chromium, steel. Now, when we talk about oil analysis in lubrication, one of the things they check for is wear metals in the oil. And if I'm starting to see, if I see a lot of the lighter metals, the softer metals, you know, lead and aluminum, that's fine. I got a lot of life in my bearings. But if I'm starting to see a lot of, you know, nickel and steel, I'm running out of bearing. Now, this is important when you're trying to decide which trucks do I want to replace versus which trucks can I keep on the road for a while. I got a few trucks with a lot of nickel and chromium in them running out of bearings. Right? When you install a bearing, it's okay to lubricate the face of it, but never lubricate the back of it, because it will throw your torque spec off when you tighten the cap onto either the block or the rod, because grease has mass, mass takes up space. So when you torque it with grease on the back of it, you hit your spec. As soon as that grease runs out of the back of the bearing, your rod cap just got loose. And it goes downhill from there. Okay. Now these are friction tight. They have a spread to them. When you put them in the block, you'll notice you have to kind of force them down a little bit. That's that way for a reason, so the bearing stays in place. Okay. You've got a locking tab that aligns with the block or the cap. There's a relief in the block or cap for the locking tab. Okay. And you'll notice when you put the bearing in the cap, it sticks up a wee bit above the cap. That's fine, because when I torque it to spec, it's going to crush a little bit, and it's going to crush into a perfect circle. Now, can you reuse bearings? You can.
Can you, what was your question?
Can you reuse a bearing? You can, if it mics out in spec. If I measure the inside diameter and it's within spec, sure.
It's cheap insurance to replace stuff.
It is, but if I'm on a low budget, I just got to make these trucks run, and I got a specified amount of money, then yeah, I'd probably consider that.
Well, you work at Acme?
Yeah, right. Right? Well, no, there's a lot of guys that'll do that. They've got to make these trucks last a little longer because they know they got a budget in a few years to replace them. So, I mean, if I'm going to replace something in a few years, I'm going to put the bare minimum I have to get it to do the job I need it to do for a period of time. Now, for a bearing to be considered good, it's got to withstand fatigue strength. This bearing's getting beat on. So I don't need to be beaten and have it just spread out and fail. Okay? It's got to conform. Now what I mean by this is, even though the rod's been machined and polished and cleaned up, there's always imperfections in the metal on the rods. Right? So when I clamp the cap on the rod, it's going to be slight imperfections in the metal. Okay? The bearing has to be able to conform around those slight imperfections so it fits properly in its bore. I got to have a certain amount of embeddability. That means if I get a little bit of a dirt particle, I'd rather embed in my soft bearing than embed in my hardened crank. Okay? And I have to be able to resist corrosion. Where's the corrosion coming from, guys? I don't want my bearings rusting up on me, but how would they rust?
You have a leak in your head gasket?
Possibly, but I'm talking everyday use.
Air filter,
Nope, everyday use.
combustion,
How
byproducts.
about condensation?
Oh, okay.
It has to be able to resist all that too, what you guys said. Combustion gases and all that. But the corrosion is, that crankcase is not vacuum tight. Okay, so as the engine cools off, moisture is going to form inside the crankcase, and it's going to, you know, drop onto whatever it drops onto. This is one of the reasons you have to change your oil, because it gets condensation water in it. Okay. So the bearing must not fatigue under load or split under heavy load. You don't want it to fail and start spinning in its bore. That's when they say you spun some bearings. It's got a spun bearing in it. That usually damages the block, making it unserviceable. If my bearing is spinning in the block because it's fatigued, it's crushed, and it's got so skinny it can't stay in its bore, now it's spinning with the crankshaft, that's imminent failure.
How much is a bearing?
set of bearings is,
15.
yeah,
And those are good ones.
would you say 15? Yeah, Perfect Circle comes to mind. Set of bearings, yeah, they're not expensive. It's cheap insurance, right? Unless it's your car. 15 bucks, that's a 6-pack, brother.
Yeah.
6-pack and a pack of smokes. Okay, maybe not the smokes. All right. Bearing conformability is the ability for the bearing to move or shift and conform to any variations in the shaft alignment. So that shaft, even though the holes are bored straight, it's going to move a wee bit. Okay? Embeddability means the bearing should permit foreign particles to become embedded in it. Now, obviously we want to keep the foreign particles to a minimum, so you have to service your filters and your liquids, your fluid. Okay? This is another thing they'll check on a warranty. You go in with a failed engine, you know, oh, that's what I got my warranty. And they look at that bearing and they see all kinds of stuff embedded in it. At some point you're going to be going to Egypt to visit the river, the Nile. Because if they see a lot of embedded materials, they'll know you haven't been changing the oils, you haven't had the filter service. They'll even run a gas mass spectrometer and see what it is that's in it. And they'll tell you where it came from. Silicon, you haven't been changing your oil, or your air filter. Carbon. Oxidation, you haven't been changing your oil or your filter. But you won't be able to hear it over all the crying you're doing because your $50,000 truck needs a $30,000 motor and you ain't paid it off yet. So when you go into the warranty office with the warranty guy and there's a mop and bucket in there, it ain't good for you because they're going to need something to mop up your tears. Just saying.
I've seen a lady come out of the office crying,
Yep,
same thing for an engine,
yep,
$50,000,
yep.
just like that.
Now if you have money, you can get a good deal on a slightly abused truck and do it yourself and save about 20 grand.
I was on a Prevost coach, but
Corrosion, again, bearing to resist rusting or corrosion or other impurities in the engine oil. Blow-by gases, who said, yeah, you were right. And also a certain amount of pH level when it gets acidic. And electrolysis. Okay. So oil that is not maintained per OEM is going to show up in the bearings. Show up in the bearing. pH level. And again, when you go into warranty, they got a whole crew, that's all they do. They'll take an oil sample. They'll have it analyzed. They'll check the pH. They'll check the corrosion. They'll check the wear metals. And they'll know. That's all they, because a warranty is a crapshoot. You buy the extended warranty hoping something fails for higher than the cost of the warranty. They sell the warranty hoping nothing fails, and that money they get to keep. That's what it boils down to. Okay. So the backing material of the bearing is normally steel, softer alloys are bound over the backing plate to make the bearing surface. Okay. And it sees wear metals that'll show up in an oil analysis. This is how you judge what's left in your motor. The life. So they're Babbitt bearings. So you'll see stuff in them like copper, aluminum, lead, brass, chromium, nickel, steel. The harder the metals get, the less bearing you got left. Okay? Now, let me go back here for a minute. So when the oil sample is taken from the engine, it's been in service for a while, the oil is going to be analyzed for wear metals. Now when we get into lubrication, I'm not looking for what's left in my oil, for the life left in the oil. There's no way I can tell the additive package level of the oil. The oil analysis is simply to tell the maintenance program what are the wear metals in the oil. If I've got highly acidic oil, what's that telling me? I've got a lot of combustion gases getting into my oil. So what's that tell you? What's that? Possibly. Incomplete combustion due to low pressure or heat. Could be head gasket. Right? Over under fueling. Okay? If I've got raw fuel in my oil, diluting my oil, leaky injector, something like that. Okay? I've got coolant, cracked block, bad head gasket. That's more likely the cause. Cracked head. Okay. So that oil analysis program can go a long way to a newer fleet maintenance manager back at CR&R, right? So Chris would get his analysis on his fleet, and he could schedule major work using that analysis as one factor deciding which trucks are more tired than the others. Okay? One factor, mileage, cost per mile, how much it costs to operate it, using more fuel than the others, this sort of thing. Okay? So if he's got to put trucks to the auction because they're getting new trucks, he can pick the worst of the bunch. And one of the factors that Chris would use is, well, I got a lot of bearings going south. So if I've got an opportunity to throw away some trucks and not have them in my fleet anymore, the ones with the, chromium, nickel, steel will be considered. And again, oh, well, this one costs X amount of miles to run because it's such poor fuel mileage, because it's got such bad compression, and it's running out of bearings, and it's using oil, and blah, blah, blah. Right? And he's got a whole spreadsheet that analyzes this, and then within a period of time, he can tell his boss, get rid of this truck, this truck, and that truck, and here are the reasons why. Pretty close to that, Chris?
It's exactly what it is. You can also use it to figure out what your intervals are gonna be too.
Sure. If he's got a set of trucks that he has to keep, because he's not gonna get another budget to replace them for another 4 years, okay? He's gonna decide which ones to throw away, which ones to keep, and what kind of money he's gonna need to put into them. All right? So if you just got a lot of wear metal but not a lot of combustion gases or blow-by, he says, okay, I'm running out of bearings. I can roll a set of bearings in this thing and run it for another period of time until I start seeing high acidic level, high combustion gases in the oil, and then I'll maybe think about putting that on the chopping block for the next go-round. I mean, it's a job. It's a job. And a lot of it's an educated guess, and every now and then you'll miss the boat. You'll miss one. Want to get by. Hey, I thought you said this would last. It just blew up last week. Well, hey, I'm not perfect. Right? That's what a maintenance manager does. And they have the same guy doing this for our buses. Okay? Which ones are coming due? Okay? Now, so when the crankshaft of an engine is running, okay, we're in service, we're running, it's going to be stretching, torquing and untorquing, stretching and flexing and doing all kinds of weird things. Okay? So every time this thing fires and stretches and compresses and twists, it's going to vibrate. It's working vibration. Okay? Like I said earlier, everything has a natural vibration. That's just physics. That's molecules running around in our atoms, or atoms and molecules. I don't know, I was going to skip that part of class, but everything's moving around. They have a frequency. If my crankshaft's operational frequency meets its natural frequency or harmonics, we're going to have a huge problem. It's going to fail. Okay? So a problem will occur when the natural frequency of the crankshaft and its operational frequency equal each other. It's going to break. Okay? Now, how soon will it break? Don't know. Can't predict that. Damage is usually catastrophic. Crankshafts don't kind of fail. They don't sort of need service. They go. We had an engine come in here. I don't know if you were with us or not, correct? The first 3 cylinders were running. The back 3 were not. Crankshaft broke. It's running bad, of course. And my front pulley's turning. The back of it just broke. Clean break on the number 4 German. Clean break. We took it out. It's like, damn, someone cut this in half. The Sawzall. It was awesome. It's like, blah, 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 blah. I'm like, it's kind of running. 3 cylinder. Now, the guy shut it off. Now, here's the funny part. So they shut it down. He says, oh, Oscar wants to see it. Fire it back up. So he hits the starter. The back 3 start turning. The front's not turning. Oh, crap. Crankshaft broke. they took it into rebuild, split it open, and it's like, it was one of the cleanest mechanical failures in a crankshaft. And the fact that it didn't detonate, take the whole block with it, it's 1 in a million. 1 in a million.
The block was still usable? Or no?
I don't think it was, because it was moving around quite a bit in there. The liners were failing. It did a lot of damage. But the fact that it was running, it's just beyond me. Now, so we have a harmonic balancer, okay? Or you'll hear it called vibration dampener. And that's exactly what it does. It smooths out the rotating crankshaft, lessening the vibrations developed so it doesn't get into harmonics with its natural frequency. Okay? So it also helps smooth out the firing impulses. So it's not so much, you know, bang, 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 bang. Because again, if you could put a slow-mo camera on that crankshaft, it would be doing this. It looks smooth because our eye does not have a capture refresh rate fast enough to see that. Y'all see what I'm saying? We look at it running and boy, that's sure turning good. It's real smooth, right? But in actuality, it's not. It's very abrupt, if you will. It's very jerky. Okay? So the dampener, this particular is called a fluid-filled dampener. It's probably one of the most common used. It has a solid rubber ring inside of it, floating in a very thick, viscous fluid. Okay? So the case rotates around the ring. The ring is rotating at a much different RPM than the case. Okay? But they're both rotating. And as long as they rotate, the vibration of the operation of the crankshaft will be absorbed by that internal rubber inertia ring and the viscous fluid. Now, where you can go wrong on these things is if I have to pull this off the end of my crankshaft because I have to service my crankshaft, some guys will get the wrong kind of puller. They'll get a claw puller and they'll put a claw behind it here and a claw behind it here and pull it off. And then the claws will dig in and put a little divot in the back of the puller. And if the divot's big enough, it'll lock that inertia ring in place, not allow it to free float in the viscous fluid, and now your dampener is not damping. Now, I don't know how long it'll take to operate a dampener like that before you have a crankshaft failure, but it will happen. So, most dampeners will have small threaded holes to thread your puller into the solid metal part of the dampener and pull it off from the face. That way you don't risk putting a dent in the case.
Because that thing is a soft metal?
No, it has nothing to do with being a soft metal, and that's a great question. It has to do with the clearances in here between the rubber ring and the fluids are not a lot. It's very tight. It's loose enough to let that rubber inertia ring float independent of the operation of the case. So if I grab it and put a slight divot in there, that might be just enough to lock that thing in place. And now I don't have the two independently rotating components. Now I've just got basically another pulley. This is pretty stout, but okay. So it kind of looks like that. Okay? I've got my hub, my metal back, my rubber inertia ring floating independently of the case. So if I put the wrong puller on there, and I put a little divot here locking that ring in place, this thing ain't gonna work. So I'll have to use the holes usually provided to pull it just by threading a stud in, and using a puller to pull it out by these, not clamping a puller behind here and here and trying to pull it off. Do people do it that way? Yeah, and they get lucky. Because maybe it didn't take a lot of effort to pull it off and it just came right off and they're like, oh, okay, it's okay to do this. But if you get one that's been in there a while, you're mill-free, I'm quite sure that thing didn't just jump off the end of the crankshaft. He probably had to work it a little bit.
Probably not.
Yeah. Okay, and if you use the wrong kind of puller, put a pretty decent sized divot in there, and then he goes through all the trouble of building it, puts this oh, it looks good to me on there, and blows it up. And there goes all the money you did on that rebuild, because it's just now toast.
Pull it out with a pry bar too.
Yeah. I mean, if you can grab it and wiggles and it comes off, great. And it's wiggling and you get a pry bar back here on this part of it, not here, and work it off, that's fine. But if you're prying on here, you're courting disaster. Okay? They have another kind of dampener out there that's not as popular with the large engines that rerun. It's a dampener rubber bond. It's basically a big rubber round inertia spring that kind of absorbs the firing impulses of the engine. Okay? The rubber springs will attach to an inertia ring, this ring here, and as this thing rotates and fires, it causes this rubber spring to kind of load and unload and absorb the impulses of the firing. Is it used on our kind of engine? No. It might be used on smaller, lighter things, but it hasn't been used in our class of engines in quite some time. Okay? Now, the other end of the engine, the flywheel end of it, okay, so this dampener goes on the front. I'm sorry if I didn't say that. This goes on the front of the crankshaft at the front of the motor, front of the engine. Okay? On the back end of the engine, we have the flywheel. Big, heavy flywheel. Okay? It's heavy for a couple of reasons. One, it helps smooth out the firing impulses of the crankshaft. Two, it serves as a mounting surface for whatever the engine's turning. In our case, the transmission, but it could be a generator, it could be a pump, it could be any number of things. Three,